Welcome to this explainer. Today, we're taking artificial intelligence, which, let's face it, is a massive buzzword right now, and breaking it down into a clear, evolutionary journey. Because we interact with AI every single day, right? Every time you scroll through your social feed, let a spam filter clean up your inbox, or just let a streaming app pick your next movie, you're interacting with AI. But we rarely stop to look at how it's actually built. So what exactly are we dealing with? Well, by looking at AI as a ladder of technological growth, we can understand exactly what level of intelligence is operating behind the scenes in our daily lives.
So let's just dive right in and answer that core question. Is AI just one giant sci-fi supercomputer locked in a basement somewhere secretly running the world? Well, no, not quite. Because AI isn't a monolith. It's definitely not one all-knowing singular brain. It's actually a super diverse spectrum. Think of it as an entire ecosystem of different programs and algorithms, all categorized by very specific capabilities. Some can literally only do one basic task, while others are inching closer and closer to human-like versatility.
To make sense of it all, we're going to climb the evolutionary ladder of AI across 5 stages: the data detectives, the content creators, the memory evolution, the human connection, and finally, the big picture scope. Let's kick things off with stage 1, the data detectives, which is all about making sense of information.
We begin our journey with the foundational types of AI that act as analytical time travelers. They sift through the mountains of data we produce every single second. Actually, a great way to think about this progression is like going to the doctor. Step 1 is diagnostic or descriptive AI. This is the doctor figuring out exactly why you're sick based on your past symptoms. It looks backward to perform root cause analysis. Step 2 is predictive AI, which looks forward. In our analogy, this is the doctor forecasting exactly how your illness will progress if you don't change anything. And step 3 is prescriptive AI. This evaluates all the data and writes the exact prescription you need right now to get better, telling you the absolute optimal course of action.
Now, predictive AI is kind of like a fortune teller for businesses and researchers. It relies on advanced techniques to group similar data points through clustering and classification, which helps it predict customer behavior or market trends with just unbelievable accuracy. For instance, it uses things like decision trees, which are essentially massive flowcharts of if this, then that scenarios, and propensity models. A propensity model is basically a scoring system that calculates the exact likelihood that you're going to do something, like click an ad or buy a product. By mapping out these massive models, it assesses the probability of future outcomes based entirely on the hard data it has today.
But here's the real game changer. Prescriptive AI goes far beyond just guessing the future. It proactively recommends and executes actions to change that future. Just consider how credit card fraud prevention works today. When an unusual charge happens halfway across the world, the AI doesn't just sit there and guess the fraud might be happening. It actively steps in. It instantly blocks the transaction, triggers an automated text asking if you made the purchase, and freezes the account until you reply. It identifies the next best action, securing your money, and executes it instantly.
Moving right along to stage 2, the content creators. This is where AI starts mimicking creativity. Generative or cognitive AI represents a massive leap up the ladder because algorithms are finally stepping out from the world of pure numbers and into the role of a creator. We are stepping into the realm where systems begin to act like artists and authors, genuinely mimicking human creativity. This is the tech behind the chatbots you use to draft emails, or the tools that generate those photorealistic images from a simple text prompt. By automating complex, repetitive tasks that usually require a human touch, this stage saves enormous amounts of time. It isn't just crunching data anymore. It's producing entirely new content, drafting complex software code, and generating articles practically out of thin air.
You can really think of generative AI as a digital multi-tool for the modern age, balancing 5 distinct capabilities. It isn't just about making funny pictures for the internet. It can offer expert advice by acting as a specialized tutor on coding. It generates completely new text, audio, and visuals from scratch. It enhances our cybersecurity by intelligently analyzing complex threat patterns in real time. It actively assists us in daily digital tasks, like summarizing massive documents. And finally, it drives powerful automation across entire industries, allowing human workers to ditch the manual labor and focus on high-level strategy.
All right, let's step up to stage 3, the memory evolution, how AI learns and adapts.
Because, without memory, there is no true learning. Reactive AI is kind of like a chess computer from the 1990s. It looks at the board exactly as it is right now and makes a highly calculated move based on predetermined rules.
It has zero memory of the past. It doesn't remember if you used the exact same trick to capture its knight 3 moves ago. Limited memory AI, however, fundamentally changes things because it actively uses past experiences to inform its current decisions. It doesn't just react to the present, it learns from history, adapting its approach so it doesn't fall for the same trick twice. It actually evolves.
If you've ever been amazed by autonomous vehicles navigating busy city streets, or a recommendation system seamlessly suggesting your next binge-worthy TV show, you are seeing limited memory capabilities in action. Think about a self-driving car. It doesn't just take a static snapshot of the road. It remembers the trajectory of a pedestrian walking toward the crosswalk over the last few seconds, calculates their speed, and predicts if they're going to step into the street. By identifying these patterns over time and combining them with historical data, these systems continuously adapt. They learn the rules of the road, and they become incredibly accurate through the sheer power of memory.
Now we're entering some wild territory. Stage 4, the human connection, emotions, and consciousness. Leaving behind the AI that works behind the scenes today, we are now looking at cognitive evolution, where technology attempts something truly staggering: understanding the human mind. Theory of mind AI seeks to predict our intentions based on context, reading our emotional states to engage with us naturally. Imagine your GPS not only rerouting you around a massive traffic jam, but detecting through your driving patterns that the delay is making you stressed and automatically switching your radio to calming music. That's theory of mind. It aims to recognize emotion and conduct social interactions just like an empathetic friend would.
But hey, quick reality check. Your smart fridge isn't currently judging your midnight snack choices. It is vital to remember that theory of mind AI is purely in the research stage right now. There's a hard line between what is science fact today and what is strictly science fiction. While brilliant researchers are actively working toward giving machines emotional intelligence, we simply aren't there yet. This level of empathetic connection remains firmly on the horizon.
Taking the evolutionary ladder to the absolute extreme, self-aware AI would be the most advanced form of artificial intelligence possible. This is the holy grail, and, depending on who you ask, the potential terror of computer science. A self-aware AI would possess its own independent consciousness. We're talking about a machine that has its own feelings, desires, and a fundamental sense of self-preservation. It would be able to self-diagnose, evaluating its own health and internal emotional state without needing any human intervention or programming to do so.
But again, purely theoretical. We really need to reinforce the boundary between real-world tech and Hollywood blockbusters here. There are absolutely no machines with a sense of self or an independent consciousness secretly living in our servers today. Reaching this final rung of the ladder requires breakthroughs in computing and neuroscience that we can't even fully conceptualize yet.
Finally, let's pull it all together in Stage 5, the big picture scope: narrow versus general AI.
Let's categorize everything we've learned into 2 overarching buckets for a big picture perspective. Think of narrow AI as a high-performance race car, absolutely unbeatable on a smoothly paved track, but completely useless if you drop it into a swamp. General AI, on the other hand, is like an all-terrain flying vehicle that can autonomously figure out how to navigate literally any environment it encounters. Narrow AI is built specifically for a single lane, completely lacking generalization. But general AI operates with human-like understanding across entirely different domains.
Here is the crucial takeaway. Despite how incredibly impressive modern technology seems right now, we are still 100% in the narrow AI phase. Whether it's prescriptive fry prevention, limited memory autonomous driving, or generative image creation, it's all narrow or weak AI. That's because it relies entirely on hyper-specialization. A chess-playing AI cannot suddenly decide to write a poem or drive a car. It's incredibly powerful, sure, but it is strictly confined within its predefined scope.
General AI, or strong AI, would possess the astonishing ability to transfer knowledge autonomously from one entirely different domain to another, just like human intuition allows you or me to do. A general AI could theoretically learn how to play the piano, and then take the abstract mathematical concepts it learned from music theory and apply them to solve a completely unrelated problem in advanced quantum physics. It represents true, cross-domain autonomous decision-making that isn't limited by its initial programming.
So, as we wrap up this explainer and our journey up the AI ladder, I want to leave you with a pretty massive question to ponder. We've conquered the lower rungs, right? We've mastered data, creation, and memory. But how will humanity adapt when we finally cross that bridge from narrow AI and build a machine with strong general intelligence? Will it just be a tool, or will it be a colleague? Keep exploring, keep questioning, and I'll see you next time.